right, so factoring difference of squares is as follows. It is something that you already know how to do because you know how to factor a trinomial. So let's say I had an x squared plus a 0x minus a 49. Now, you might say, well, why did you write 0x? Because that means nothing. You wouldn't have to write that, correct? But if you had to factor this trinomial, you would set up your brackets. You would think about FOIL. And what numbers give you x squared? X and x. And what numbers give you 49 so that the outside and the inside make nothing? 7 and 7. And one would have to be plus, and one would have to be minus. Correct? So that's exactly the same kind of factoring we've done as before. The difference this time is they'll never write the plus 0x because nobody writes plus 0x. This will just start off as x squared minus 49. But you'll still be able to factor it because there's still a first term, a last term, and the outside and the inside just disappeared. Does it make sense? Can you see that they would just disappear? And you can go directly from this to that for factoring. And it's called a difference of squares because difference means subtraction. There's a subtraction in between. And both the first number and the last number are perfect squares. 49 is 7 times 7, and x squared is x times x. Oh, not done yet? So try these ones on your own. So first of all, you recognize it as the difference of squares. There's no common factor. You have to think of this as your first and your last, and the outside and the inside just sort of disappeared. Well, it would have to be x and x. To get 4 would be 2 and 2, and one will be positive and one will be negative. And it'll always work out that way. Because the outside and the inside would disappear then if one is positive and one is negative. Is 121 a perfect square? Yes. X and x, 11 and 11. One positive, one negative. Doesn't matter which one you make positive and which one you make negative, as long as one is positive. What about 36? Is that a perfect square? Yes. X and x, 6 and 6. One positive, one negative. All right. Next ones, level up. All right. Let's see how you did. First of all, is 9 a perfect square? Yes. Is 144 a perfect square? Yes. How many people did this to start with? 3x, 3x, 12, and 12. 1 plus, 1 minus. All right. Did anybody keep going? Because there is a common factor in each of those. There's a common factor in 3 and 12. What could you pull out? You could pull out a 3, leaving you with x plus 4. Is there a common factor between 3x and that 12? Yes. You could pull out another 3, leaving you with x minus 4. Those 3's could be put together, and you'd have 9x plus 4, x minus 4. So you have to keep factoring until there's no common factors and everything is factored completely. I put this 3 and this 3 together to get 9. Okay? Now, had you seen right from the beginning there was a common factor, you could have done that. Is there something that divides both 9 and 144? 3. and 9. Do you know the trick for dividing by 3 and dividing by 9? 144 adds up to 1 plus 4 plus 4, 9. If it is divisible by 9, you can divide it by 9. So that's harder to see. Most people would just see, oh, perfect square, and go directly what we did here in blue. However, if you see that you could pull out a 9 to begin with, you would have got this. And now inside, can you see that's still perfect squares and a difference? Difference of squares. X, 4, 4, 1 plus 1 minus. And it's the same answer. So you could choose whichever way, the blue way or the green way, to go first. Is 25 a perfect square? 49 a perfect square? Is y squared a perfect square? And x squared is, so we can go directly here. Bracket, 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 bracket. Here it'll be 5x and 5x, 7y and 7y, 1 positive, 1 negative.
No common factors.
And no common factors, so this was nice. We're done. Any common factors in the next one?
Yes.
What can you divide them both by? 2. That would give you 1532, and you could divide that again by
I was originally
2.
thinking after I.
So the best way would be to pull out a biggest common factor between these from the beginning is a 4.
Actually, I was more so thinking along the lines of first doing.
I'll do it both ways. So if you pull out the 4 first, then you have a difference of squares here. 5a minus 4b plus 4b. If you factored it directly, which most of you did, right? Most of you went, first of all, 10a, right? Minus 8b plus 8b. Can you see that you can pull a 2 out of both of those? Leaving you with 5a minus 4b. Pull a 2 out of that one, leaving you with 5a plus 4b. Putting those 2's together will get you the same as the blue answer here. Just takes one more step. It's the most prettiest arrow I've ever made.
It's the most.
Most prettiest. All right.
Grammar fail. No, thank God this is an English.
2 more. Is 5 a perfect square? No. And 500 is not a perfect square.
Oh, oopsie, I didn't notice that one. I was looking at the X4.
The x4 is a perfect square.
Oh.
So try those 2.
Well, I'm stupid.
Did you see that there's a common factor between these? You could pull out a 5, leaving you with x squared minus 100. And the inside is a difference of squares. X plus 10, x minus 10. How'd you do?
So it doesn't matter which.
It doesn't matter which way you write, which one's plus and which one's minus. X to the 4 is a perfect square. What times what is x to the 4? X squared and x squared make x to the 4. Then we would have plus 1 and minus 1. And if this was on a quiz, I would make this question out of 2 marks. And we currently would get 1 out of 2. What's wrong? What can you do?
Have X. They break down the X squared.
Which one? This one? Or this one? Or both? Okay. How would you break down this one? This one first. You're saying you could break this one? What would you say? Would you think x plus 1 and x plus 1? To get x squared plus 1? But if you FOIL this, you'll get x squared plus 2x plus 1. So that doesn't work. So that one can't be factored anymore. But the other one is a difference of squares. Right? Square, square, difference. This one's not a difference of square because there's a plus sign, but this one is it, so you can x and plus 1 and minus 1. If I wanted to be really crazy, I could put a big number here, like 64. Because watch what happens with this one. 64 would be 32 and 32, right? That makes 64. Plus 1 minus 1. Second one's a difference of squares. So then you'd have x to the 32 plus 1, because that one can't be done anymore. But this one could be x to the 16 and x to the 16 plus 1 minus 1. Are we done? No, you could keep going. Oh my goodness. You have to rewrite this all out. And this would be x to the not 4. Remember, when you're multiplying, you add the exponents. It'll be 8. 8. Plus 1 minus 1. Good, we're done. No. You could do this one as a difference of squares. It will end. What makes x to the 8? X to the 4 plus 1 and x to the 4 minus 1. Oh my goodness. And x to the 4 minus 1 is this, right? Whoa, just wait for it. Let's go here. All this stuff, let's put it. Oh, I need to get that one more bracket in there. There we go. And then we clone it. Okay. I'm going to try to do something fancy. No, I don't know if it'll work. I just wanted to drag this in and put it here. Oops. Whoa, easy. See?
Still, I was right. It is a never-ending loop.
It'll go all the way. This would have to get repeated, so I should copy this part. Oh man. It's not working. It's taking too long. We could have a puzzle. I could do this and I could say, put it back together so the math makes sense.
Well, there's some of the numbers that just like come apart.
I know, that makes it even harder. Because you take something like this and you go, oh, that one's not. But this, here, this one, I can. Wherever your pen. Oh, it is in the video. Okay, we'll keep going. All right. Da-da-da.
It's a never-ending loop of factoring. It's crazy. It's like a time loop but with factoring.
I feel bad for people who are in our class just watching those videos for help. They're just sitting there.
I'm just having fun. We all forgot it.
Yeah. So all the football players are going to watch that going, how am I going to write all these notes down? Whoa.
Like 10 minutes.
The last slide of the unit before the homework.
Oh my gosh. I feel so happy.
And probably the most important unit for grades 11 and 12 was this unit. Mm-hmm. As far as a skill that you need to have moving forward, this unit was the most important.
This is like the addition and subtraction.
Example of where we would use this.
Yeah, I feel like I
In your
need to,
everyday
like,
lives, well,
I need some.
if any of you go into any science of engineering or anything like that, you're going to use this high-level math. Well, this will be the basic level math for that. So if you're deciding to go into those sciences or architecture or anything like that, and you're doing architectural engineering, then you'll need all of this kind of math for that.
How about like our everyday life? Like if we chose not to go through that.
In your everyday life, like an application of difference of squares? Okay, I'll give you one. Let's finish this first, and then I'll give you an application of difference of squares. Here we go.
I feel like I'm not gonna find this ever, so I feel not.
2a plus 5. How do you do? That's all you have to do is figure out what's missing. Okay, so here is an application. Mental math. Okay? Sometimes you have to do mental math because you don't have a calculator handy. So let's see if you've done. Let's see if you've got some mental math. Let's see if you can do 30 times 30. Good. How, on a level of 1 to difficult, how was that? 1? Okay. 29 times 31. Mental math, level of difficulty just went up to? Just went up to difficult. Okay. Good. Now, what have we done here? What have I done is I've added 1 and I've subtracted 1. That's all I did. What do I know about x plus 1 and x minus 1? It's a difference of squares. Difference of squares is equal to x squared minus 1. What's my x here? My x is 30. You just told me what 30 squared was. 30 squared is 900. This is 1 less. It's 899. That's using difference of squares to do some mental math.
Wait, what? This is oh, wait, times 30 is 60. And 9 times 1 is, oh, I get it.
You get it? You see it? Did you ever notice that? Did you ever notice that with your times table that 8 times 8 is 64 and 7 times 9 is 63, 1 less? Yeah. And when you do 9 times 9, that makes 81. And when you do 1 more and 1 less, it's 1 less. And 7 times 7 is 49, and 6 times 8 is 48. It's always 1 less. And that's just a little easy application of difference of squares. What happens if you add 2 and subtract 2? You get x squared minus 4. That's a difference of squares. So now you can do 28 times 32. You just have to subtract 4. It's 896. Yeah. You wanted an application, and now you're asking to go to the washroom? Don't absorb things in the bathroom. That's a bad idea. Okay, you can go. Here's your homework. That's also in the video. I better stop this.